So let's make sure we can also fetch a single post. And for that, I'll go to my schema again, because on the schema is where I will work. And so here, I will add a new query, post, which will get an input, an ID, of that single post I want to fetch, and will return a post in the end. This is how my query should look like in the schema definition. Now let's of course also add a resolver for this single post. For that, I'll go to my resolvers.js file, add it down there, use the async function syntax, like this. And in that function here, just as in the function up there, I'll get arguments in the request object. With object destructuring, I can get my post ID, or whatever you chose as a name here. So in my case, just ID. Out of that request arguments object, I get the request object as well. And first of all, I can check whether the user is authenticated. So I'll copy this check and add this here. And then as a next step, I will add the logic to retrieve a single post. And for that, I'll get my post by awaiting post find by ID for the ID I get as an argument. Now I will also populate the creator here so that we have all the user data and not just the ID. And thereafter I'll check if we did not find a post, in which case I'll create a new error, no post found. And I'll set a code of 404 and throw that error. But if we make it after or past this if check, we know we have a post. And then I'll return an object where I get all the data from that post. And then again, I override the ID because I can't return object IDs. So post underscore ID to string. And the same for created at, because I can't return dates. Created at to ISO string, and updated at will also be changed to ISO string. With that in place, I have everything I need to fetch a single post, I'd say. Let's now go back to the front end and wire that up. And there, I'm interested in a single post in the, well, single post page here. In there, in component.mount, I'm sending my request, and I'll again adjust the URL to go to localhost 8080/GraphQL. The method here will be a post request. For the headers, I add my content type application JSON header, and I will need to prepare my GraphQL query here, which is, as before, an object with a query key, and then the query is surrounded by these backticks. And in there, well, I want to reach out to my post query. I will send my ID, so my post ID I get up there should be surrounded with quotation marks. And regarding the fields that I'm interested in, well, thereafter I use the creator name, the title, the image, URL, the date, the created at date to be precise, and the content. So I want to fetch that. I want to fetch the title, content, image URL, creator, and for the creator only the name, and then also created at. That is what I'm interested in. And this is now what I will append as a body to my request. So JSON stringify and add this GraphQL query here. With that, we are sending that request. As you learned before, handling the error there will not really work. We want to handle that error after we parsed the response data, and then we can check for errors. So I'll copy that logic from feed.js into single post.js here, where I check if we have any errors, and then I throw an error. If we have no errors, we just need to drill into the response. And for that, you must not forget how your schema looks like. We'll have data, then we have that name of the query, which is post, and then we can access our different post properties. So here we access res data.data, and then indeed .post.title and so on. So just .data has to be added to all these places where I extract some data. And with that, I should be able to load a single post. Save that and make sure your backend is saved. And click on View. And looks like I have an error in my URL. Yes, this colon needs to go. Now let's click View. I get user login failed. That is the wrong error message I copied there. Fetching post failed. But somehow it fails. Let's quickly check what's wrong. Yeah, there is a syntax error in the query. We need to have surrounding curly braces around the overall query. So edit your query to have a opening and closing curly brace right at the start and end. And thereafter, if you click on a single post, now you load the post data there. So this is now working. What's missing is a possibility to edit and delete posts, and of course to work with the user status. So let's work on that next. Now that we can load a single post, let's make sure we can also edit a post. And as always, that journey starts on the backend. There, in the schema, we want to add a new mutation, because obviously editing a post is a mutation. I'll name it update post, and I expect to get the ID of the post I want to edit, and then some post input, which is my post input data. So the exact same data I expected to get for creating a new post. As a result, I will return the updated post. So this is my schema. Now on to the resolvers, where I will add update post as an async function again, where I get my arguments. I will have the ID and the post input and the request object. So this is my update post resolver. In there, I first of all want to check the authentication status and throw an error if the user is not authenticated. Hence, we can copy the code from our other resolver functions where we had a similar check. And then I'll first of all get my post by using await and post find by ID, and using that ID I extract as an argument. I'll also populate that with the creator so that we have the full user data when we return the updated post. Then I'll check if we don't find a post, and I can copy that check from up there to return an error in that case. And if we do have a post, well, then I want to check if the user who tries to edit it is the user who created it. And for that, I'll check if post creator underscore ID to string, if that is equal to request user ID. And that also converted to a string. If these two match, then I know this user is the creator. If they don't match, so if I add exclamation mark here, then I know someone tries to edit the post who's not authorized to do so. And in this case, I'll again create an error, not authorized. Could be the error message we throw. I'll add a code of 403 and I'll throw that error. And then we can't continue. If we are the right user, however, we can now edit the post and set the title equal to post input title. We could now also add validation, by the way, and we should. So I can scroll up to my create post function and grab that validation logic. All the logic beginning from the empty array being set up to the errors being checked. And that is something I also want to do before I start editing my post title and so on. But now here I know that the input is valid. So now I will edit my title. I will edit my content. And I will now also edit my image URL if it changed. And that is not guaranteed, because if the user did not select a new image, the image will not have changed. So I'll check if post image URL is unequal to undefined. And now this has to be checked against the text, because it will be converted to text. By the way, I'm sending it on the front end. So if this is undefined, then I will continue. But if it is not undefined, then I'll also overwrite the image URL with the new image URL, of course. Otherwise, I will not touch the image URL. And then I'll have my updated post by awaiting for post save. And I will then return my updated post here or some data. I will return my updated post doc data and again replace the ID with updated post ID to string, and the same for the dates. Created at will be replaced with updated post created at to ISO string, and updated at will be replaced with updated post updated at to ISO string. So this is the response I want to send back to my client here. With that, we got a resolver in place. We hopefully got everything in place we need. Let's now go on to our React application. And there, in feed.js, we need to find finish added handler. So if we scroll down, in this function, in the finish added handler function, we will always send our image to that endpoint. Though, of course, it could be the case that there is no image to append if no new image was chosen, but that will be fine. We do handle that scenario in our endpoint, right? In post image, we check for the existence of a file and we send a response if no file was provided. So thereafter, here we continue, and we'll have a file path, though that file path might very well be undefined. And that is why in my GraphQL API, I check for it being undefined. We could handle this in different ways, of course. We could alternatively simply keep the old file path here then, if this is undefined. But I will go with this approach. And then we send the GraphQL query. Now, of course, it will not always go to create post, though. It might also be that we added a post. So I'll check if this state added post is true-ish, which means we are editing. And then I'll set GraphQL query to a different query. So to an object where my query then looks differently. I will copy this query in general. So I'll copy all the code between my opening and closing backticks, like this. But of course, I'm targeting update post here and not create post. So I'm targeting this mutation here. And there I also need to pass in different data. I need to pass in my ID, which I get from this state edit post underscore ID. I still pass in the post input as before. That did not change. And I still want to get the same data back. So that also does not change. Then we send that request. And in the handler of the request, I already have some logic that should handle this correctly if we are updating. So let's save that all and let's give it a try. Let's reload and let's edit another duck and add a couple of exclamation marks without adding a new image. And I get an error here. In general, though, it looks like it worked. I have my exclamation marks here, and the image, the old one, is also still there. I can also still view that, and here I see the change too. Now, regarding that error, well, that is related to how we extract data from the response. We access create post, but of course, if we send an update post request, then this field in which our response data is stored will be named update post and not create post. Therefore here, and we can, by the way, validate this here, it's stored in update post. Therefore, what we can do is we can add a new variable, response data field, or whatever you want to name it. And by default, that should be create post, because creating a post also is our default query up there. But then I'll add a if check, and I'll see if this state edit post is true-ish, in which case the data field where I want to extract the data will be update post. And now we just need to use that variable here to dynamically retrieve our data. And we can do that by selecting all these create post instances here with the first dot and replace them with squared brackets where we pass in rest data field. And this will now use the value inside of rest data field to access, well, a property with the name of that value on our data object. And now, if we reload, we should be able to remove the exclamation marks and try out choosing a cup as an image here, accept, no error, and we see the cup here too. So this all seems to work. The status and deleting of posts are the remaining things that don't work. Let's finish the post functionality by making sure we can delete posts. And as always, feel free to do that on your own as a practice. Create the appropriate query or mutation and the respective resolver functionality on your own. And feel free to edit the front end too. After a short pause, which you can use to pause the video and try it on your own, we'll do it together. Were you successful? Well, again, we start in the schema of our backend. And I'll add the delete post mutation here. And I expect to get the ID of the post, which should be deleted. I will then only return a boolean that indicates whether that succeeded or not. This is my mutation. More interesting is the resolver for that. So let's go to the resolvers file here. And there I'll add delete post. I'll retrieve the ID from the incoming data package, so to say, from the arguments object. And I'll write this in the async function syntax again so that I can use async await. And again, I'll start by checking the login status. Now, obviously, you could refactor this into a common function. I deliberately have the more verbose setup here to make it really clear that we have this check in every of these resolver functions. After knowing that the user is signed in, let's fetch the post we want to remove so that we can check whether the creator of the post is the user who tries to delete it. So we get the post by awaiting for post, find by ID, with the chosen post ID. Now here, we can check if we don't have a post. And again, this is some logic we can copy from before. And the same is true for our authorization check regarding the quality of the creator and the logged in user. So I'll copy these two if statements in here to check if the post exists. And then I want to compare the creator with the logged in user. Now important, since I don't populate my creator field here, the creator here is not an object with underscore ID, but creator itself is already the ID because that is how it's stored in a post. And we need to call populate to change that in the result. We're not doing that here, so we only access creator to directly get the ID of the user who created the post. Now we got all the checks in place we need, and after this, we want to delete the image that belongs to that post. Now for that, I have that functionality in app.js here. Now I will copy that and put it into a separate folder, util, where I will add a file.js file. And in there, I will just import path by requiring path. And it will import the file system by requiring that core node module. Now in here, I can export clear image so that we can use it in other files. And I want to use it in app.js, where I already did use it in the past. There, I don't need the file system import anymore, but I will add an import to my own clear file functionality by requiring util file. And then here I use destructuring to get that clear image function. So this is now using that restructured code where I moved that function into a separate file. And in the resolver, I can now also import that. So here I also want to import clear image by requiring, and here I need to go up one level, then the util folder, and then the file. So now I have clear image available. And now at the bottom of my resolvers, in that delete post resolver here, I will call clear image. and pass my post image URL in there, because that is the path of the image on my server. Now, after this was done, I will await the result of post find by ID and remove. And I'll do that for my post with that ID. Once this is done, I just need to make sure I remove that post from my user as well. So for that, I first of all need to get my user by awaiting user find by ID for the user ID stored in my request object due to the auth middleware we added earlier. And on that user, I can then access the posts and pull my ID, so the ID of the post which I just deleted. And thereafter, I will await the result of user save to save that updated user back to the database. And then I will return true, because remember, in my schema I defined that I want to return a Boolean. I could wrap this all with try catch, this part, to also then return false if it fails. And that is generally something we can do on all these resolvers. I will not do it here to keep this code a little bit more simple, but in the end, that is something you could add. Important is that you here return true. That is the backend. Let's now work on the front end as well, and let's make sure we can trigger the deletion of the post there. For that, in the feed.js file, you want to go to the delete post handler, and there again, define your GraphQL query, which has the shape you already know and love. In that query here, I'll run a mutation, the delete post mutation. The ID here is injected between double quotation marks. It's the post ID I am getting as an argument. And we have no nested object here, so we couldn't even get any nested or detailed data. We only get true or false. That is my query. And then here, again, I'll send this request to localhost 8080/GraphQL. The method, as always, will be a post request. We add our token. We also set the content type to application JSON. And of course, we need to add our query expression as a body by using JSON stringify and passing our GraphQL query in there. We don't handle errors like that, as you learned. Instead, we do it on the parsed response, because that is where we would have an errors object if there are any errors. So I'll copy that code from above and then move that in here to check if there is an errors object, which means something did go wrong, and then deleting the post would fail. And that is it. Now let's save that as well as the backend code, and let's click on delete here. And that is looking good. And I can carefully delete all my data unless there's only until there's only one duck left. And if I now refresh my posts, only one duck is there. And in users, that user still has 2 ducks or 2 posts. But that is probably related to something I deleted earlier behind the scenes, which is also the reason why I have 2 images here. To validate that everything does work, let's delete that. And on that user, let's manually delete the 2 array elements, clear all the posts as I mentioned, clear all the images here. And now reload. We have no posts now. Let's create a duck. And let's give it that duck image and some content. Let's also create another item, a cup, and give that the cup image here. We can now view the cup, we see it. We also see the duck here. Now let me delete the duck. The cup is still there. Only one image, this is looking good. If I inspect my users, only one item, the cup, so that now makes perfect sense. And now let me also try logging in with a different user who didn't create that, and their deleting indeed does not work. So we have all that in place. Let's now finish this all up by making sure we can view and edit our user status. And again, this is a great challenge for you. We're almost done. Let's now make sure we can also view our user status and delete it. And as I already mentioned at the end of the last lecture, this again is a great practice for you, so definitely feel free to try this on your own first. Pause the video now and implement these two functionalities. Of course, we'll also do it together after a short pause. So, did you succeed? Well, let's try it together. And I'll do both in one go. I need to add two things, one query and one mutation. The query is for getting the status. And actually, since we're not using the approach I mentioned earlier, where we add a new endpoint for everything, we have to remember that with GraphQL, we can control which data we get back. So I will add a general user query without any arguments, always for the currently logged in user. And I will return a user object here. Now, in my mutations, I will add my update status mutation. I could add an update user mutation if I generally would be fine with the user changing. Since I have no such functionality planned in my app, I will only add a special mutation for just the status. Otherwise, we could, of course, go with a more generic approach here too. There, I expect to get the status as a string, and I will return the updated user. With that, we can move on to our resolvers. Let me add the code for returning a user, so for this user query. There, I get no arguments, so I get that object, but I will not retrieve anything from there. And again, I will write this as an async function to be able to use the await keyword. I'll then check if the user is authenticated. If he's not, then, well, we have a problem. And I will not continue. Otherwise, I will get my user by awaiting for user find by ID. And I can use the user ID stored in the request. And on that user here, I'm interested in the status, right? That's the status I want to return. So if I find no user for that ID somehow, then I will basically do the same I did when I found no post. I'll return an error, no user found. If I do have a user though, then I will simply return a response. And that is my whole user data. I just will make sure to replace the ID with user underscore ID toString. So I can now theoretically fetch all the data about a user I'm interested in. But obviously I'll implement that in a way that I only fetch the status. And that is something I do here in my feed.js file of my frontend application. There in component did mount, I send a request to an endpoint which does not exist anymore. Instead, we're now of course targeting GraphQL. The method here will now be post. I will send the token, but I'll also set the content type to application JSON, and I'll set the body to my query. And that query is something I need to create up there. GraphQL query is a constant I'll create here. That is our object with the query key, which again is surrounded by double backticks or single backticks, but I need two, opening and closing. And here I'll send my request to my user query, or I'll use the user query. And all of the data I get back, I'm not interested in the name or the email. I'm only interested in the status. That is my GraphQL query, and that is what I'll send in stringified version to that endpoint. Again, handling errors like this will not work. Let's instead grab the code we have below here, where I just check for the existence of the errors object after parsing the request body. So here, fetching status failed would be my error message. And when I extract the data, I need to drill into the data field and then the status field. Now, if I save that and I reload, I got an internal error here. Cannot return null. Let's quickly check our resolver, the user resolver. I return my user object here, but I did not save it, I guess. This now looks better, but I'm not seeing the status here, and I got an error, about which I'll take care in a second. My status here is not found in data. I have to drill into the user field as well. We can see that if we go to the network tab and have a look at that request, where we got that data, we got data, and in there, user, which is the name of our query, of course. And I forgot that, but obviously, query name is always where the data is stored in. And that then has the status field. So this is a change that is required. And now with that, we see the status, and this error message also is gone. Like that. So this is it. Now let's also make sure we can update a status. And for that, let's first of all make sure we do something for this schema we added, for the update status schema in our resolvers file. So this is the last resolver function I'll add here, update status. I'll get my status argument and the request, of course. And I will, as before, use my async function syntax. And in here, I first of all will check whether the user is authenticated. If that's not the case, we throw an error. And then I'll get my user by awaiting for user find by ID for the request user ID, so for the logged in user. If I have no user, then we got a problem. So I will copy that code from above and throw an error if that's the case. Otherwise, I'll set the user status to the new status I'm getting as an argument, and then I will await user save to save the updated user. I can then return an object where I take my user doc data and where I replace the ID, so user ID, with the stringified version of it. And this is my update status mutation. Now, last but not least, I also need to edit this on the front end. So in my React app, and there we simply search for the status update handler here, where we of course send a request to GraphQL, and that should be a post request. The headers are all right, and I will define my GraphQL query here is an object, the query key, my backticks of course, and the query now is a mutation with the name update status or whatever you defined in your GraphQL schema file. And there I need to pass in the status, which is a string. So we need double quotation marks around the value, which I'll now inject here. And the value is this state status. This is where the status is stored, which the user enters into the input field. And of the data I get back, I'm only interested in the status. Then we want to send this here in a stringified version. And again, we don't handle errors here. We handle them as we do up there, checking for the existence of the errors object in our parsed response data. And that is already it. Now if I save that and save the backend as well, if I add a couple of exclamation marks and I click update, seems to succeed, and we can validate this by reloading. If I now log in with a different user, there of course we should not see that updated status. There we see the status of that user. And with that, we moved our entire REST API over to GraphQL. And I hope you see the power GraphQL gives you by being more flexible regarding the data you fetch from the backend. And therefore, your front-end development can move faster because your backend gives you the entire bandwidth of data you might be interested in. Now, finally, before we leave that module, there's one thing we can optimize now. Because there is one thing which I did in a way that is okay to do, that will work, but that is not recommended doing, and that we can do better. Whenever we pass a dynamic value to our GraphQL queries, as we are, for example, doing it here, where I do have a page, we currently do use the interpolation syntax here, where I use this $ curly brace thing to inject or interpolate a value into my string literal. Now, this absolutely does work, but this is indeed not the recommended way of adding variables into our GraphQL query. There is a better way. Maybe you also remember that for mutations we had to add mutation here, but for queries, we didn't have to add query here. And indeed, if we would have added query like this, we would have gotten an error. Well, now I will add it because now I will also add something else. I'll give this query a name that does not really make a difference. It does not make it behave differently. It will help in error messages, for example, but that name then also allows us to do something else. So here we are, of course, getting all posts. So here I'll name this fetch post, and you can give this any name you want. So this here is totally up to you. Now with this name assigned, I can add parentheses after this name to define which variables this query will use. And we create such a variable here with a $, but then no curly braces, and then the name of the variable you want to use. And that name is again up to you. I'll name it page, but you could have named it current page, whatever you want. This will be of type integer, so you assign a GraphQL type again here, and this is really important to understand. This is GraphQL syntax here. This will be parsed on the server. This is not JavaScript code that runs in the client. This will only tell our GraphQL server that we have a query which will use an internal variable. Now that I'm saying internal, the question of course is, where do we use that $page? Well, we use it in the place where we do have a dynamic, a variable value. And that would be here where we currently inject our value. Now I use my $page here, and this name here has to match this name, and it has to start with a $. And now GraphQL knows, okay, this part here is dynamic, it might change, and it will be an integer because we're defining this here. So now the only question is, how do we get our page variable here in JavaScript into our $page variable here in GraphQL? And for that, we add a second property to that query object we're creating here. Thus far, I only have the query expression. Now, after that, I'll add a comma and I'll add a second property, which are my variables. And this has to be named variables just as this here had to be named query. This now is the query expression, and variables now is an object where we can assign values to the variables we pass into our query here. So here I have $page. Here it then should be just page without the $, and then my JavaScript variable or value. So I could pass 1 here to always use the first page, or in my case, I do have that page constant or variable here in JavaScript now. So this is the value I want to assign here. Now I have page 2 times, but the first page refers to the internal variable used in the GraphQL query, and the second page after the colon refers to my JavaScript variable, just to make this clear. And now with that, let's save this, and let's reload our application, or first of all, let's quickly log in there because I was logged out. And now here, you see, I get my post. Now if I add another duck here, and I then add one more item so that we do have pagination going on. Then after reloading, we can indeed see that this works as before. I can switch between my 2 pages, and I simply have 2 cups in there. By the way, maybe you noticed that we didn't get that next and previous link after we created our item, our new item. That is something we can fix too. But for now, let's focus on the variables. And there, in our front-end code, this is how we use variables. And technically, it works just as before, But this is the more elegant, the better way of using variables in your GraphQL queries. So now we can replace that in all our queries. For example, in this mutation, there I also use string interpolation to get my value in there. Better would be to give this a name, update user status or anything like that, and then define which variable we need in here. That would be the, let's say, user status. Again, this name is up to you. And then the GraphQL type of that, which will be a string. Then here, without the double quotation marks, because we define it to be a string, you add user status like this. And then again, you add a second variable to that GraphQL query object, where you add that variable's key, where you now assign a value to that variable you defined here, without the dollar sign, and then the value you want to store there. And in this case, this would be this state status, just as before. Now, if I continue here in the next query, where I do edit or create a post, there I'll also give this a name, create new post, seems like a fitting name here. And there we'll have a couple of variables, which is no problem. We can, of course, have more than one. We'll have the title, which is a string. We'll have the content, which is a string. And we'll have the image URL, which is also a string. And now, just as before, we use these values in here. So title, content, and of course also the image URL. And now we just need to add that second argument here, the variables, so that we can store our title. And you might remember, this was post data title. Then the content was post data content. And the image URL, well, that is our image URL variable in JavaScript, or the constant, which I'm creating here. Now, when we edit a post, update existing post could be a name we assign to that. And there we also have some variables. And there we will need our post ID, let's say, which is an ID. We then also have our title, which is a string. We then have our content, which is a string. And now, just as before, I'll copy that value because I'll need it in a second. But then I'll replace this here with post ID. I'll replace the rest in a second too. Let me first of all add my variables below that. And then here we have that post ID, which is the value I just cut out. And then here we have the post data title and the post data content. So here we use the title. There we use the $ content, not wrapped in double quotation marks. And we also have the image URL up there, which is also a string. So we should also, of course, use the image URL here. And now we need to assign values to these variables down there too. So we have the title, which is post data title. We have the content, which is post data content. And we have the image URL, which is image URL. Always remember the first part here, so the key name in our variables object, refers to the variables we defined here without the $sign. The second part after the colon, so the value of our key value pairs here, refers to the value we want to pass into that variable. Now, time for a little save to just check if that is all working. So now if we create a new post, another duck, because as you can tell by now, ducks are lovely animals. It's still lovely. If I accept that, then we seem to have an issue here. So that did not work. And the problem we have here can be found when I inspect my GraphQL request, which fails. There I get some errors. And we see that all my variables here of type string expected a type string which is required. And that, of course, is my mistake here. We should add an exclamation mark here, because if we have a look at our backend, at our schema here, we have a look at our mutations there, then we can see that create user has user input data and create post has post input data, and that is what we're working on. And that input data, the post input data, indeed does require all these strings. The page previously was optional. There we had no exclamation mark, which is why I did get no such error before. For the status, by the way, we would also get an error because the status, as you can tell, also has a required string. And that is really important, and therefore good that this slipped through. The types you assign in your frontend here for your variables have to match the types in your backend schema. So here, for example, in create new post, all my strings here are required. And for update existing post, well, there, for update post, we also have the same type of data and a required ID. So we should make sure that we add that exclamation mark after all these values here, because they are required in our schema. They have to be required in our front end too. So let's add this also on update status. So after this change, let me go back. Let's try this again with another duck. Entering some dummy value here. And now this is looking better. Now let me edit this by removing the exclamation mark. And there I still get an error. Image URL was not provided. Let me quickly have a look at what's wrong there. If we go to our update existing post, I do have my image URL here. And on the back end, an update post, I also do require it there. But indeed, the problem I have here is that the image URL is not always set when we don't choose a new image, right? And you might remember that indeed on our backend we have a check in update post where we see if that is undefined as a text. So I should at least pass that text in to go through that check. So what I'll do is, if my image URL cannot be set here, I'll set it to a string undefined, which is not the same as the default value of the type undefined. And with that, if we now reload and I tried it again, now that works, because now we're setting this to a value we're checking for in the backend for the use case that we don't have a new image. And then we'll keep the old image here. With that back in the front end, this is taking good shape. The other queries in feed.js are all right. In the single post JS file there though, here I also have a query where I inject a value when I get a single post. So here I'll give this a name by adding query and then a name, fetch single post. And there I expect to have a post ID, which will be of type ID, and that is required because it is required in our backend schema. Here in our post query, we do require that ID. And then here I can also assign that here. And as you learned, add a second element to that GraphQL query object, the variables property, where I then set post ID equal to post ID. So to this post ID, which I'm extracting here. And now with that, if I save this and I go back and click view, this still works without issues. Now with that, let's also go to app.js in our front-end code, because there we do sign users up and in. And here we also inject values into our query. Now, just as before, we should name these queries and use that different approach. So here I'll name that user login. And I do get an email, which is of type string and which is required. And I do get my password, which is of type string and required. And then here, where I have auth data email and auth data password, I can use email, so $email and $password. And we add that new variables object here as a property to the GraphQL query, and then email will be auth data email and password will be auth data password, just as before, but now with that more elegant syntax. And last but not least, when we sign up, so when we create new users, then I'll also give this mutation a name, create new user, whatever you want. And here, again, I expect a couple of values. I expect the email, which is a string and which is required. I expect a name, which is a string and which is required. And you can always check your backend schema to learn what is required and what is not. And here, our user input data is what we have to pass to the backend. So last but not least here, I also have my password, which is a required string. And then I'll just quickly copy that, because now I'll replace these values with my GraphQL variable equivalents. So $email, $name, and of course here, $password, and then again add that variable's object and pass email, which is auth data sign up form email value, pass the name, which is auth data sign up form name value, and pass the password, which is auth data sign up form password value, just as before. And with that, we should have replaced all injected values in our application with new values. Now let me quickly sign up with a new user here. Now let me also quickly log in with that user. And that also works. And with that, we got everything in place. I can't delete that, obviously, because I'm not the user who created it. I would have to log in with the correct user for that. So with that, everything is working the way it should. And now we have a GraphQL API that uses that new variable syntax, which is the recommended way of passing dynamic values into your queries. Now there's one thing you also might have noticed. When we only have 2 posts, so we have no pagination because we don't have enough posts to have a second page, and I add a new value like a duck here, then this duck will show up, but we don't get that next button. There is a little bug here, which is easy to fix, has nothing to do with Node.js, but it is really easy to get rid of. In our finish edit handler here, when we go down to the code where we create that new post and we then add it to our existing posts, it's this else block here, which is interesting to us, where we in the end make sure that we only render 2 items at a time and that we add our new post at the beginning of the list. Now here, what I need to do is I need to make sure that I do increase the amount of total posts. In our state, in React here, where we manage how many posts we have on that page, I do set total posts here to a different amount of posts when I fetch all posts, where I get that total post information. Well, when adding a new element, I know that total posts will simply be the old total posts plus 1. So I will add a new variable here right below updated posts, and that's updated total posts, and that will be previous state total posts. And that is a bit of React logic here, but this first of all takes the old status. And now, when I do go into the else block, which is the case when I am not editing, but when I'm adding, then I want to set updated total posts plus 1. With that plus plus syntax, I increment it by 1. And then here, in the return statement, I'll set total posts equal to updated total posts. And with this change in place, if I now quickly delete my duck again so that I'm back to 2 items, and I do add my duck so that I go up to 3 items again, now you see that next button, and you can use it, of course, because now we're managing the total post correctly too. So that's just a little adjustment, has nothing to do with Node or GraphQL, but since I spotted that bug, I of course also want to get rid of it. And with that, we moved our entire REST API over to GraphQL, and I hope you see the power GraphQL gives you by being more flexible regarding the data you fetch from the backend. And therefore, your front-end development can move faster because your backend gives you the entire bandwidth of data you might be interested in. That was a lot of content on GraphQL, and as I mentioned, you could fill an entire course just on GraphQL, and indeed there are courses on it. The official docs on graphql.org are a great place to dive deeper because they're really good, and there you can learn more about all the features GraphQL offers, including its more advanced features. In this introductory module, I hopefully gave you a good overview over the GraphQL core concepts and how you build a GraphQL API with Node, and in this case with the Express.js framework. You learned that GraphQL allows you, or is a technique to build a stateless client-independent API, just as we did it with the REST API, but that it offers a higher flexibility than REST APIs typically do, because you expose a custom query language to your client. A GraphQL API is made up of queries, which you would compare to your GET requests in REST APIs, mutations, that would be your post, put, patch, and delete requests in REST APIs, and possibly also subscriptions, something I didn't cover in this module. You use these constructs to exchange data and to manage data. And the important and characteristic thing about GraphQL APIs is that they only expose one endpoint to the client, and that is a post request to /GraphQL typically. It has to be a post request though. That is something you can't avoid. And all requests are directed there, and then in the request body of that post request, you use the GraphQL query language to describe the query you want to execute or the mutation you want to execute. The server parses that incoming query expression and then calls the appropriate resolvers to execute the logic you wrote and return the appropriate data or do the appropriate manipulation. GraphQL, and that is also important, is of course not limited to React.js front-end applications. You can use it with any front-end application, be it a mobile app, a single-page app with any framework, or whatever you have. It's not limited to React. Now, when we compare it to REST, then we have to understand that REST APIs are not strictly worse. They might still be the perfect solution for your next project. They are especially great for static data requirements, so where you don't need that additional flexibility. And then you have a very clearly structured and explicit way of defining your endpoints and defining the possibilities your API offers. So for file uploads or scenarios where you simply don't need that flexibility because you always get the same kind of data, there REST APIs might still be the perfect solution. In other scenarios, GraphQL might be better because you get a higher flexibility due to that exposed full query language your client can use. And I also want to highlight that both REST and GraphQL APIs can be implemented with any framework and actually even with any server-side language. You're not limited to Node.js, and on Node.js, you are of course not limited to Express. And that is really important. The core concepts you learned here and a lot of the logic you applied will actually be the same no matter which framework you use or no matter which server-side language you use. You did it. You built an amazing Node.js application. And in this course, we actually built a couple of applications. And we're typically not just doing this for our own practice or to do it on our PC only. Instead, we of course want to deploy this application into the web so that it is reachable by other people. Because as long as it's running on localhost, only you can reach it. And that is the idea during development, of course. Now in this module, we'll move from development to production. And you will learn how we can prepare our project for deployment. There are some things we just want to adjust or where we want to make sure that we don't skip them. We'll then, of course, also walk through all the important steps and the configuration you need to do to deploy your project to a hosting provider. And we'll talk about security because that obviously is connected to deploying your app, because as soon as it does not run on your own computer anymore, you obviously have to make sure that some things just are, well, secure. So let's dive into all these things in this module. Now, obviously, in this course, we built a couple of different applications. To be precise, we built an application with server-side rendered views, and that includes the possibility to return just HTML pages, or as we did it, to use a templating engine like EJS. And obviously we built two APIs. We built a REST API and a GraphQL API. Now, how do we deploy these two types of applications, one with views and one without views? First of all, we have to keep in mind that how the application behaves, what it does with incoming requests, and which data it accepts and returns. This is all our logic. This is all code we wrote. In the end, when we look at it from a technical perspective, in both kinds of applications, we start a normal Node server and we use a Node framework, in this case, the most popular one, Express. And therefore, these types of applications have the same hosting requirements. We don't have to make a difference here, because in the end, when we move our code to a web server, then there we also just want to do the exact same thing we did locally. We'll start our Node server and wait for incoming requests. And therefore, we don't have to differentiate between these kinds of applications when it comes to deployment. We simply deploy our code, start the Node server, and we are good to go. How do we then prepare the code for production? Now, this obviously always depends on the kind of application you're building. In general, you want to use something which is called environment variables, and I will show you what this is in our concrete projects in this module, no worries. Use environment variables instead of hard coding certain values like API keys, port numbers, passwords, and so on into your code. Also make sure that if you are using some third-party services like Stripe, that you use the production API keys and not the development keys. For example, Stripe, which we used, gave us a testing API key. Well, that is obviously what we want to use as long as we test the application. As soon as we deploy it, we want to use the production-ready API key. And that is something that also depends on the third parties or on the third-party APIs you might be using. Now, we also might have some mechanisms to handle errors or to log something. And there we want to make sure that we reduce the error output details. We don't want to send sensitive info to our users. So if something fails, if some error message is thrown, we want to make sure that it does contain as little information as possible, because the users of our website should of course not get any insights into our source code. Now, by default, and in the way we built this project or these projects in this course, we'll not have problems with that, because if we use the default Express error handling middleware and the default errors and the custom errors we build also don't contain any sensitive information, then we are fine. But if you're building an application where you create your own error objects, maybe with a lot of data added to them, you should make sure to strip some of that data out of these custom errors when you deploy your application or when you prepare your application for deployment. Regarding the responses your application sends, you want to make sure that you set secure response headers. There are some response headers, some headers you can add to any response which don't hurt, which prevent the clients from doing certain things, certain sniffings, and so on, and therefore setting these headers won't hurt. And I will show you in this module how to easily set these headers and how to find out which headers that are. So we'll implement some best practices there. Now, in a typical Node application, you might also be serving some assets, some JavaScript, some CSS files, and there, adding compression can be a good idea, because that will reduce your response size, or therefore also your response time, because the client has to download less. And most modern browsers and so on are able to download compressed, so zipped assets, and unzip them on the fly directly in the browser. So this is not some fancy mechanism where you would have to do a lot of manual coding. It's actually pretty straightforward, and the browser does a lot of the work for you. You also want to configure logging so that you are aware of what's happening on your server. Since we're now not testing the server anymore, but real users do interact with it, we certainly want to log interactions into log files that we can look into at any time we feel like it. So that is another thing we want to add so that we can stay up to date about what's happening. And last but not least, SSL TLS, so encryption of data in transit, is also something we might want to look into. Thus far in this course, we used a normal HTTP server, and therefore our communication with this server was not encrypted. For testing, this is obviously fine. Now, for a production-ready app, it's strongly recommended that you do encrypt your connections. And therefore, I will also show you how to turn that on in your Node-Express application in this module. It's also worth mentioning that the last 3 points here, compression, logging, and SSL, are often handled by your hosting provider. And I will talk about that when we choose a hosting provider, because often or typically you want to use some managed service where these things are also managed for you, so that you don't have to worry too much about that. I'll still show you how to enable it manually, but it might be worth noting that you probably don't have to do that when deploying your application. Now, after that theory, let's go back to our project. And this is our shop. So this is not the REST API, this is not the GraphQL API, this is the shop as we built it. And you can find this snapshot of it attached to this lecture. Now, in there, let's first of all explore that environment variables thing I was talking about. And we can start in the app.js file. What would we control in an environment variable, and what is an environment variable? Now, environment variables are a concept supported by Node.js where we can pass certain configurations, certain values into our Node application from outside. So we don't hard code certain values into our Node code. Instead, the values will be injected when our Node service starts. And that allows us to use different values in development and production, and also to conveniently change the values in production without having to redeploy our entire code. And a great example can already be seen here, that connection string here. This connection string allows us to connect to our Mongoose cluster, and obviously we have some hard-coded values here. The username and the password for this user, and then also the default database. If we want to change anything there, well, then we have to change it in the code and redeploy it. Additionally, if we ever share this code with someone, like I do with you, you know these credentials. Now, they won't matter much to you because I changed my password after I quit recording this course, but of course, in a real application, you can't change your passwords every time you share the code with some coworker or anything like that. And therefore, you want to use Node environment variables here. Another place where we would want to use one is at the bottom of this file here, where we set the port where this should start. In development, we use 3000, and we can basically use any number that is above the thousander range. But in production, we want to let our server or our hosting provider set this port, because that is in the end the thing, the service that does open our app to the web and that does configure all the network settings. So there we don't control the port number, but the hosting provider does. Another example for something we want to control in an environment variable can be found in the shop controller. There at the top, I have this stripe key. Not only is this the development key, which we have to exchange for the production key, but it's also not a good idea to hard code it in here for the same reasons as it was with our Mongoose data. So let's use some environment variables, and using them is straightforward. Now, first of all, I'll turn this connection URL into a template literal by replacing the single quotation marks with backticks. Now, it's still a normal string, but now we can inject values by using $ curly braces. And now here, we can access environments variables on the process object. This is an object not defined by us, but this is globally available in the Node app. It's part of the Node core runtime. Now, on this process object, we have the very helpful nth property. And that is now an object with all the environment variables this node process knows. There are a bunch of default environment variables, but we can also set our own ones. And here, let's say, I want to use the Mongo user environment variable, and I'll replace this text with it. Now, I also want to replace the password. So here, I'll use Mongo password, and I'll remove the password here, and I will show you how to set these environment variables in a second, of course. The database here, we can also replace that with Mongo default database. Alternatively, you could, of course, make that whole connection string an environment variable, depending on whether that string changes regularly or just the values inside of it. Regarding the port, I'll also go down, and here, instead of setting 3000, I'll set process nth port, or if that should be undefined, 3000. Now, most hosting providers, or all hosting providers that manage that for us, will automatically inject a port environment variable. So most of the time, we can rely on that being set. And for local development, we'll still fall back to 3000 because there it will not be set. Now, for Stripe, if I move to the shop controller, I also want to use an environment variable here. And I will use process env Stripe key here. With that, I replaced a couple of things with environment variables where it makes sense. Now, if you scroll through all the code, you might find other occasions where you would say, okay, I want to set that from outside. I don't want to hard code that. But these things which I now exchanged are definitely important ones. Now we do try to read these environment variables in our Node code. How can we now pass them into Node? Well, we do that when we run our Node application. With NodeMon, we can provide a configuration file. You can simply add a nodemon.json file in your project root folder, and there provide a JSON document, opening and closing curly braces. In there, add a nth object, and there you can now set your environment variables, like Mongo user. There the value should be Maximilian. Mongo password. So all these variables I try to read in my code, and that should be the password you just removed from your app.js file. And also Mongo database. And there I will now use shop like this. So now I added the environment variables for my MongoDB connection string here. Whoops, and that should be named Mongo default database I see. So let's rename it here too. And besides these Mongo things here, we could set the port, but there we have a default value. After the two pipe symbols, we always fall back to 3000. Now for Stripe, we also want to inject something. And there, we should sign into our dashboard. And in that dashboard, go to Developers, API Keys. Now here, for the server, you will need that secret key. And you want to move that into your NodeMon package. So there, I named the environment variable Stripe key. And that is how I should name it here too. So that would be the value. And now with that, if you run npm start, it should still start and should still connect. I get an error that Mongo default database is not defined because, of course, here in the connection string, it should be process nth Mongo default database, just as it is in all the other places. Thereafter, everything starts just fine. And now we have a running application using these environment variables. Now, these are still the development values, but nonetheless, we have that set up. Now, of course, we're not always using NodeMon, and especially when deploying this app, we'll not be using it, because there, we don't want to restart the server on every change, because we'll not change the code anyways. So, what I'll do is, I'll add a new start script to my package.json file. I'll name it start::dev. You can name it however you want. You could just name it dev, whatever you want. And there, I will use NodeMon. And in my main start script, I just want to use node. This, however, will now not use the nodemon JSON file. So if you want to pass in environment variables here, you also got different solutions. And typically, when using a hosting provider, you can set up the environment variables in the dashboard of your hosting provider. That is something we'll see later. But if you're not using that, well, then you can, as a simple solution, simply take the key value pairs you want to set up and add them in your package.json file in front of the start script. So there you would use Mongo user equals Maximilian, like this. And you would do that for all the values you want to pass in. So now we can do the same for the password, Mongo password. You simply separate it with a white space. Mongo password equals this. Mongo default database equals shop. And the Stripe key equals, and now I need to get that Stripe key here, copy that, move it here. And now we have obviously a very long startup string. Again, typically we'll not pass it in like this, but now if I would run npm start, it should still start and connect without issues to the MongoDB database, because now we are running this with our environment variables here. I also want to highlight one special environment variable, which you can set manually, and that is a special one which I just want to log here. On process env, there is the node nth variable, and now if I quit my server and restart it, you see undefined here. Now, again, this will be set automatically by hosting providers. You can, of course, also set it on your own, and hosting providers will set this to production. Now, if I restart, we see production being logged here. And this is a special environment variable, even though it's not set by default, because Express.js will actually use that by default to determine the environment mode. And if you set that to production, Express.js will change certain things. And for example, it will reduce the details for errors it throws, and in general, optimize some things for deployment. So you want to set this when running your app in production. And again, hosting providers typically do that for you. You can always check out the official docs of your favorite hosting provider to find out if that is the case. Now, I did mention on the slide that you also want to exchange testing keys for production keys. And in our case, that would be that Stripe key we're using here through environment variables, which we do set in the nodemon and in the package.json file. Now, obviously, that always depends on which kind of APIs or third-party services you are using. Maybe in your app you use no service at all, and therefore this is not an issue for you. With Stripe, what you want to do is you want to click on that to switch to public or to production-ready data. Now, you need to activate your account here to be able to do that, as you see. And to activate your account, you have to fill out some information, including some payment information. And therefore, I will not do that here. But if you were to deploy this into production, you need to fill it all out. And once you filled it out, you will be able to switch that toggle here at the top and see your live data, your production-ready keys. And you should use these keys in your code. So wherever you are using the test keys right now, you would have to replace them with the production-ready keys. And that is just a Stripe example. Other APIs you might be using might have a similar behavior. Now, we already prepared some things for production. Let me now dive into that secure headers thing. And for that, we'll use a third-party package, which is called Helmet. And you can use it to secure your Node-Express applications. Now, you can dive into the official docs of this package to learn more about it. And in the end, what this will do is this package will add certain headers to the responses you send back. And it follows best practices for doing so. You see which attack patterns or which security issues these are against which it protects you by setting the right headers. So definitely check that out to learn more about these headers and why it protects you against that. Using the package is very easy though. In your project, you just run npm install -- save helmet, and then this will be downloaded. And you can use it as you see here by simply including it as a middleware, and then it will automatically run on all incoming requests and therefore also have a chance of adjusting the responses as you learned, and it will then set its headers. So you can simply go to your app.js file then, and there import helmet by requiring it like this. And then as a next step, you add this line here after you initialized your Express app, maybe in the place where we then also set up all our other middleware down there. Here we can use app use helmet and execute this as a function. And this is it. Now with that, if I run npm run start :dev, my new script I added to use nodemon, everything runs as before. But now actually, if I visit localhost 3000 here, and I open my network tab and I reload this page, I can see that on this response, I have a couple of headers being set, and there are some special headers which were added by helmet here. And you can always check that by temporarily commenting out helmet. It will automatically restart since I'm using nodemon. We had 11 response headers before. If I now reload this, we just have 6, because now some special headers are missing. And that is something you should consider doing. Read through the official docs to learn all about the headers it is adding, but it's definitely worth looking at that and probably worth using that. Now with response headers added, let's make sure we serve optimized assets. And for that, we can use another package. If you Google for node compression, you'll find that Express.js compression middleware package, which makes it easy for you to add compression to your application. It's actually super easy, but you can learn all about the configurations you could add if you wanted to here in this official documentation. But if you want to add it in a very simple and standardized way, you just run npm install -- save compression like this. The package is called compression. And after you installed it, you go to your app.js file, and there, just as we imported helmet, we'll import compression by requiring it here. And we then add it as a middleware. So let's maybe add it right after helmet here by running compression as a function as well. Now you can configure it as mentioned in the official docs, but you can also just run it like this. And now for that to see an effect, I'll comment this out and save, and the node server therefore reloads. And now I open the network tab and I'll reload my page. Now these are the sizes of the assets we're downloading. Especially have a look at main CSS and main JS. Obviously these are not super big, but still this is the size of the assets as we download them by default. Now I'll comment that back in that extra package and save it. And now if I reload that page, you will see that these assets got a bit smaller. And obviously this will matter more if you have more front-end assets in your application that you need to serve. So this is compression in action, and this is worth considering, especially in apps where you have a lot of CSS and JavaScript code you are serving to your users, or in general where a lot of files are served to your users. By the way, image files are not compressed here because that actually makes it longer to load them. But this is a nice addition. I also want to note that, again, most hosting providers you might want to use have some support of compression built in, or might at least offer this compression support, which you can conveniently add there. So then they will compress assets on the fly, and you don't have to do it with your own middleware. And then you actually shouldn't do it. But in case your hosting provider does not support it, or you're building your own server, then this is a nice middleware which you can add. Now we had a look at compression and headers. Now logging is also something that matters. For that, I'll quit my server and I'll install a new package with npm install -- save, and that is called Morgan. And that is a package that makes logging request data really simple. Now, after adding it, I can, restart with npm run start dev, my nodemon server. And now to use Morgan, I'll import it here in the app.js file. I'll require Morgan like this. And now we can use it as a middleware also before we handle all the requests. So also maybe up here, we app use Morgan and we execute this as a function and pass the information on how to log this into this function. Now you find more in the official docs that simply defines which data is being logged and how it's formatted. I'll go with combined. And now if I save that and I reload this page here, you find some logging data here in the console. You see detailed logging information about the incoming request, that we had a GET request, which browser I used, which operating system, and so on. Now, obviously, we typically don't want to see that in the console when we deploy our application. Instead, some files would be nice. And to log that to files, we just have to add something here. We can create a new constant, the access log stream, use the node file system, which is a core module which we have to import by requiring fs here. And now with that, we can create a write stream with create write stream. And this allows us to then define a path, best with path join, seen from our current folder on, to, let's say, access.log, so that we will write the logs into this file.